We're going to give our WhatsApp chatbot a full voice experience. And by the end, not only will our WhatsApp chatbot be able to convert speech into text, it will have the ability to respond back using a voice message. And before we jump into coding, I have prepared a small diagram for you that details how we are going to approach this. We have our user Bob. When Bob sends an audio note, our speech transcription model, which is going to be self-hosted, is going to convert that audio into text. The audio is going to be fed into Llama 3.2 or GPT-4, whatever version you're using. Then the large language model is going to respond to the user's query using text, which we then convert into speech in order to respond back using a voice note to the user. Both the speech transcription and the text-to-speech models are going to be self-hosted. So let's get started. For the first part, which is converting an audio note or a voice message into text, we are going to use Faster Whisper Server. Let me open my browser and go to the Faster Whisper Server repository. And I hope you could tell from the name that it's a high-performance implementation of OpenAI's open source Whisper module, which is responsible for converting audio into text. And the beauty about Faster Whisper Server now is it's OpenAI compatible, which will make more sense when we are actually integrating Faster Whisper Server with our WhatsApp chatbot. So let's scroll down. And as you can see, it has both GPU and CPU support. My fellow comrades who are GPU poor like me, you're welcome. We can run this on CPU. Let's scroll down, copy the Docker command for CPU only installations. If you have a GPU, copy the command above. Let's open our terminal, paste the command. Before running, let me just break down what the command does. Run is responsible for running the container. Publish, it's a way of mapping the port on our host machine to a port in the container itself. When a request is made on the host machine on port 8000, it's going to be forwarded to our container. Then the volume is responsible for sharing a directory from the host machine with the container. And in our case, when we download a module for transcription, the moment we restart the container, it's going to use the cached version, which is on the host machine, because we are caching the module data and preventing re-downloading the module. Then detach runs the container in the background so that we don't need to keep the terminal open. Our container will just run in the background. And the last one just specifies the image. So let's click enter, type docker ps, list the running processes. You see that our Faster Whisper server has been created. We can now interact with our speech transcription model. When we go on the browser, port 8000, we have a web client where we can play with Faster Whisper Server. I have a file which is on my desktop for the purpose of demonstration. Attach it, and let's just play it before transcribe it.
Regarding the bill you're currently discussing, if you say you can handle it, then find a way to take care of it.
Let's click submit. So the first time that you run it, it's going to be a little bit slower, but after that, it will use the cached version, the pre-downloaded model. So it's going to be fast. Let's submit again. When we look at the output, the transcription went well. Our speech transcription model is now in place. So to integrate, let's go to our project. I'm going to use WebStorm. Feel free to use any IDE that you're comfortable with. Let us make a new branch for this feature. It's always good practice rather than working on the main branch. You don't want to mess up the main branch of the project. It's better to do the implementation on a separate branch. After we're done, make a pull request, get it reviewed, and then merge it into the main branch. So to create a new branch, git checkout -b feature. Let's call it voice messages. We are now in that branch. And using the Nest.js CLI, we are going to create a module for all audio-related functionality. Later on, we are going to incorporate text-to-speech. All the logic related to audio processing is going to be in this audio module. To do that, let's type nest g module. We're using the nest.js generator module audio. If you just want to see what it will do, use the dry run command. It's like a simulation of what the command does. It will show you what's going to happen without committing it to your project. So you'll see that it's going to create a module called audio. So let us remove the dry run command. As you can see, our module has been automatically imported in our application module, meaning to say it's now available to use application-wide. If you want to gain a deeper knowledge on how this works, I would recommend the first video of this series where we dived deeper into how Nest.js works. And for us to be able to convert the speech into text, we need to download the voice message submitted by the user. Let us go to our WhatsApp service because we are downloading the voice note from WhatsApp. So it's good that we put that code in the WhatsApp service. Let us create an asynchronous method called download media. The process is the same, whether it's a PDF file, an audio note is the same. So let's just give it a generic name, download media. And for us to download the media, we need file URL, which is a type string. The process of downloading a media file is a two-step process where the first step is given an ID of a file. You get the URL first from the WhatsApp server and the URL expires in 5 minutes, and then you make another request to download the file. So let's create another asynchronous method which is responsible for getting the media URL given the media ID. To make the GET request, we are going to use Axios. If you don't have it installed, open the terminal and just type npm install Axios. This then installs Axios for us to be able to make the GET request to obtain the URL for downloading our audio note. So let's import Axios from Axios. Let's also import Axios request config. Then we scroll down to our get media URL asynchronous method. And inside a try catch block, it's always a good idea to fail gracefully rather than crashing the program. That's why we are going to put our network request inside a try and catch block. Constant response await axios.get. We need to specify the URL, then the configuration. It specifies the authorization bearer token. We then specify a local variable for the URL, then give the media ID. Instead of using the global URL, let's use the local one, as the global URL is only applicable when we are actually sending a message. If the request is successful, we then return the response.data, which contains the URL that we can use to download our audio note for conversion into text. And if it fails, let us use the logger. After that, we just return. But just looking at the method, you can see that there's room for improvement. How would we know that the response from this method is the actual URL or it's the error message? Because both of them, they are strings. Rather than explicitly checking if the response contains an error message, we can change it so that the method returns an object with the response status and the data. Object status success, and then the data, which is the response.data. We do the same for the error message. Let's say status, error, then data. And since we are using TypeScript, we can explicitly specify the return type of this method such that when we are referencing it, we get autocompletion. So let's give it a return type. It's a promise, which gives an object with a key, status, which can be an error or success, and then another key, which is data, which is a string. The configuration header for downloading is different to when we are sending a message. So let's just copy the global one, paste it here, constant config. The response type is an array buffer. Since it's another GET request, let's just copy the code for media URL and adjust. The URL that you're going to use is the media URL, which we can get from our previous method. Responsible for getting the media URL constant is equal to this dot get media URL. Instead of the file URL here, we actually need the file ID. Since it's a promise, we use await, and if our URL status is equal to auto-completion again, since we specified the return type. If it's an error, we want to throw, and then this error is going to be caught by the catch block, therefore failing gracefully, because without getting the media URL, we won't be able to download the file. After fetching the URL, we then use URL.data, which contains the URL from which we can download the file. And in terms of the configuration, we are going to use the local configuration with a response type, which is an array buffer. It's a stream of binary buffer, which we're going to write in our file system. So let's use config here. TypeScript will shout at you saying the argument type is incompatible. And if you remember well, when we imported Axios, we also imported Axios request configuration. So the config here is of type Axios request config. And after that, our TypeScript error has been removed, and let's correct this to array buffer. Since the same method applies when you are downloading PDFs, audio files, or any file that can be attached using the WhatsApp client, how then do we identify the file type? We can use the response header. Constant file type is equals to response dot headers dot content type. From the file type, we then extract our file extension. Split this is going to determine whether we're going to save our file as an audio or as a PDF or whatever file format that has been sent by the user. In this case, we're only looking at audio files, but always keep in mind that it could be any file type. Our program has to be flexible enough. Then we also need the file name to which we are going to write our binary data into, because the response that you are getting from the WhatsApp API, it's an audio stream, not the actual audio. And for us to save that, we are supposed to save it into a file on our file system. Our file name, our file ID, then dot file extension. We also need to specify the folder in which we are going to save our downloaded audio message into. I'm going to call it audio, but feel free to give it whatever name you want. The folder is going to be in the root path. So for that, let us import path. Import O as path from path. Scroll down to our method. Constant folder path is equal to, we use path, and to put it in the root of our project, we use process dot current working directory, the folder. Let me rename it to folder name for clarity. Put a dot join here, and inside that folder path, that's where we are going to save our file. So we have to specify the file path again. Let's use path.join, and we use the folder path and the file name. And using the file path, we then take the array buffer and write it to our file. So for that, we are going to import fs. It enables us to interact with our file system, writing to a file, reading from a file from our system. We use the fs module. From fs, we want to write a file synchronously. We would also use write file, which is the async implementation, but I'm going to use write file sync for purposes of this tutorial. Let's then scroll down to our download media method. We use write file sync, give it our file path, then the data that we are going to write into that file, the array buffer, which we get from response.data. Then for our response, we just return the file path. With this, we are now able to download our file in our root directory. In our project, we would even improve the project to say, you know what, when the folder doesn't exist, then automatically create it. Let's scroll up and import exist sync, make directory sync. Let me demonstrate by implementing how they work. In our download media, before we write the file, check if folder exists, not create. In order to check if the audio exists, we use exist sync, our path, which is the folder path. And here we want a case where if it doesn't exist, then we create it asynchronously. Then we give it a folder path as well. And in order to test our program, let's go to our WhatsApp controller and let's make a case statement for audio, because we had a case where we're only dealing with text messages. Now that we've incorporated audio messages, if the message type is an audio, we want to download the message first such that we can then use our speech transcription model to convert the audio into text. So it's constant audio ID is equal to message dot audio dot ID. And for now, we just want to test if we are able to download the audio files. So let us call the WhatsApp service, download the media, supply it with the audio ID. For us to test our chatbot, let us start our development server, npm run start dev. We need to expose our local environment over the internet such that we can be able to verify our WhatsApp webhook. WhatsApp webhook verification enables our server to be able to receive WhatsApp messages from our user. So we're going to use ngrok or grok, whatever you call it, grok http 3000. Press enter. This exposes your local environment to the internet. Copy the URL and let us go to Meta for developers. Under configuration, we put our webhook, then specify the webhook verification token, which is defined in our environment file. Click on verify and save. Our webhook has been verified and we can start to interact with our WhatsApp chatbot. But before we do that, if you have not set up a permanent WhatsApp access token, like we did in the first video in this series, then go back to API setup, click on generate token, reconnect, copy the access token and open the environment file and change the WhatsApp Cloud API access token. And since Nest.js won't be able to detect changes in our environment file, we need to stop our development server and run it again. You stop Nest.js server, not ngrok, otherwise you have to do the WhatsApp verification again. And the moment of truth, let me go to my WhatsApp chatbot. What is live? Saying error fetching URL. Let's go and investigate. Now WhatsApp service. Let us just log the URL that we're getting. Let us try again. Test 1, 2, 3. There's our issue. In our download media, we are using url.data, but the actual URL is contained in url.data.url. So let us go back to our get media URL. And instead of responding back with response.data, say response.data.url, as that gives us the actual URL. Reload the application. Testing 1, 2, 3. And that was successful. And you'll see that in our audio folder, we have a .org file that was saved, which is the file that we sent to the WhatsApp chatbot. So the next step, we are going to take the audio file and convert it into text. Then we later on feed the text into our large language model to give a response back to our user. Rename audio into audio files to avoid confusion, since in our source we have our audio module, which is responsible for audio processing. So let me just rename it to audio file, change the folder name to audio file, then delete this one. And we also want to make sure that we don't end up committing this folder to our version control system, whether it be GitHub or others. And to do that, we go into our git ignore file, ignore the audio files folder. The folder and its contents are not going to be tracked by Git. We then move on to the actual process of transcribing the audio. Let us create a service called audio, which belongs to our audio module. We're using the Nest.js CLI, so make sure that you have it installed. You'll see that the service is now part of the audio module. In the audio service, let us create an asynchronous method responsible for converting audio into text. Convert audio to text, and it needs the file path, which is a string, and the return type is a promise, which gives back a string. Faster Whisper Server is OpenAI API compatible. The transcription is pretty much straightforward because we're going to use the OpenAI library or the OpenAI client for the transcription. Let us open the OpenAI service, copy the import, put it in our audio service, and then we also copy the OpenAI class instantiation and paste it in our audio service. Then we override the base URL. We're just telling the library where to send the request to. The URL is on our local host 8000/version1. Let's copy it and paste it here. And with this, the request that we're going to make is going to be sent to our Faster Whisper server, which is locally hosted, in order to do the speech to text conversion. Const response is equals to this dot OpenAI dot audio dot transcriptions dot create. Then we specify the model, and in our case it's not Whisper 1. You can go to Faster Whisper Playground and choose any model you prefer from the list, but the Faster Whisper Small from Systran is perfect for our use case. It does well for a small model. So we are going to copy this one, specify the model, then the file, and then we use the file system to read the contents of our audio file and send it. So let us import fs. Then from fs, use read file sync. So say read file sync, then the file path. And since this is a network call, it's on our local system, yes, but it's a network call. We wrap it in a try-catch block. Learn to fail gracefully. The file is expecting a buffer, so let's use create read stream. Then if there's an error message, we return an object with status, which is an error. Then the data, audio transcription failed. And if the request was successful, we return an object with status, success. Then the data is our response. Then let us change the return type, status, error, or success. Then the data type string. Then we await, since it's a promise, response.text. To see if the speech transcription is working as expected. So let us go to our WhatsApp controller. We get the file path of the downloaded file, since the download media URL responds back with the file path, just response. And if there was an error downloading the file, we can proceed with the transcription. Let us just return for now, but we would send a generic message to the user saying there was an error downloading your audio file. If it was successful, we then want to supply file path to our transcription service. Import the audio service from source. Then we register it in the constructor. Transcribed speech is equals to this dot audio service, convert audio to text. Then we give it our response.data, which contains the file path of the downloaded file. So for now, let us just console log the transcribed speech. Then transcribed speech. Let us put in a wait here since it's a promise. Transcribed speech dot data. Moment of truth. Hello there, how are you today? Let us open our console. Oh, our program cannot find our audio service. To fix that, let us go to the WhatsApp module and import the audio service. This will make the audio service usable in our WhatsApp module. And reload. What is live? It says what is live in the console, highlighting that our transcription service is now working as expected. Before we go into the text to speech conversion, let us just forward the user's request to our large language model such that when they send an audio message, we respond with a text message for now. Then we integrate sending audio messages later on. You'll find that sending the transcribed text to our large language model in order to respond back to the user is fairly straightforward because of the modular approach that we were using. If you go to the OpenAI service, the generated AI response just requires a user ID and a user input string, which in our case is just the user's query. The user ID is required in order to get the conversation history for that user from our Redis, such that our large language model is going to give cohesive answers. It is that same module that is being used here in the WhatsApp service. In the method responsible for sending a WhatsApp message, it calls the OpenAI service to get the response from the large language model, and to use a locally hosted open source model like Llama 3.2, you can just install Ollama and point to that Ollama instance. I've shared the link to the video where we did that implementation in this video's description, but you can also use OpenAI. If the response status from the transcribed speech is an error, we just return, then we just await and call the WhatsApp service, send WhatsApp message, then we specify the message sender and the user input, which is the data from our transcribed speech, then the message ID. Just remove this console log. It's no longer necessary since we are responding back to the user. Moment of truth. Let us go to our WhatsApp chatbot. How are you today? Our AI system has responded back to the user's audio message using a text message. For a complete experience, it would be good to also send back a voice message if a user contacts the chatbot using a voice message. So let us now implement text-to-speech conversion. We're going to use Piper, which is a local neural network that works even on CPU. So let us go and search for Piper. Go to the GitHub repository. And for the purpose of this integration, we are going to use Piper HTTP, which is a Docker image that runs the Piper HTTP service, meaning we can make HTTP requests to the Piper server and get back an audio file from text. So let us scroll down, copy the command. Let me clear my terminal. Paste the command. The -e specifies the voice model that we want to use for our system. And how do you go about choosing the appropriate voice model that you want? Go on your browser and search for Piper TTS2. With Piper TTS2, you can install any Piper voice on your browser and test it and see if it's suitable for your needs. Piper is multilingual, but for this tutorial, I'm only going to be using the English voice model. So I'm going to choose based on popularity. So let's install Alba, scroll up, select voice, and speak.
It is a period of civil war. Rebel spaceships, striking from a hidden base, have won their first victory against the evil Galactic Empire. During the battle, rebel spies managed to steal secret plans to the Empire's ultimate weapon, the Death Star, an armored space station with enough power to
So for me, I'm going to use Alba. And for me to be able to download this specific voice model called Alba, let's go back to the terminal and copy the Hugging Face link, because the voice models are hosted on Hugging Face. Then paste in the browser, go to Files and Versions. I'm interested in the English voice model, but you can choose another language. English GB, then Alba, medium. We are interested in the Onyx file. So click on the Onyx file and copy the download link. Go back to our terminal and replace the link with the one for your model. Port mapping, I'm going to use port 8084 for Pipe HTTP. Detach for the Docker container to run in the background. Press enter. If we say Docker PS, you'll see that our faster Whisper server was started 30 seconds ago, and it's listening on 8080 on the host and forwarding 5000 in the container. And to test that our text-to-speech model is working as expected, let me go to the desktop and make a curl request to our faster Whisper server. It's on port 8080, and we've specified the data as hello world. We're going to save the response, which is an audio, in a file, a WAV file called SEN. When we go to our audio file, click on music, let us play it.
Hello world.
Our voice model is looking great, so it's now time to integrate it with our system. Let's go back to our project. In the audio service, we want an asynchronous method responsible for converting text to speech. And in order to make the HTTP post request, we're going to use Axios. So let us go to our WhatsApp service, copy the Axios import, paste it in our audio service, check this whole try and catch block. The logic is the same. Then we take the config here, put it there, but the content type for our case, we are just supplying the text. So it's application text. We don't need the authorization header. It's only applicable when we are sending requests to the WhatsApp Cloud API. And instead of a GET request, we're using POST. Let us define our URL in a variable, and it's HTTP localhost port 8080. Best practice is saving this in the environment file. I will leave that as an exercise for you to do. Then the data is our text, then our configuration. Let us also import the Nest.js logger. After converting the text into speech, we're also going to save the audio file in the audio file folder, just like we did when we were downloading the voice message. So let us import write file sync from FS, and FS means file system. In order to avoid collisions where we end up overwriting some data, let us make sure that each file name is unique, and we can achieve that by giving it a file name of date.now, which gives the milliseconds since epoch, then dot the file extension .org in our case. To make our project robust, let's just check again if the audio files folder doesn't exist. So let us copy this code and paste it. Constant folder name, audio files. Then if the folder doesn't exist, we create it. Then we use write file sync to save our audio file. Data is response.data. And here we just return the file path. Let's change the error message. Error converting text to speech. Instead of responding back to the user using a text message, we want to send a voice message. So to achieve that functionality, let us go to our WhatsApp controller. Instead of sending a WhatsApp message, we just want to generate an AI response. So in the WhatsApp controller, given that transcribed speech, we want to call the OpenAI service, copy the import, put it in the controller, and let us initialize it. This OpenAI service dot generate response, and it requires the user ID, which is the message sender, and the user input, which is our transcribed speech. Let us save it in a variable called AI response. It is this AI response that we now want to convert into an audio file. So we await this dot audio service dot convert text to speech. The text is AI response. Let us test this for now and see if the text-to-speech conversion is working as it should. Before we do anything, to make the process cleaner, let us go to the audio service and save the audio folder name in our environment file. Let us then refer to this environment variable so that we only change the name in one place. Process.env.audio files. Also go to the WhatsApp service. Change it here. And for the change to take effect, let us restart our application. npm run start dev, because Nest.js is not going to automatically pick the changes that were done in our environment file. So we have to manually restart it. I'm going to delete the contents of the audio file. Moment of truth. Testing 1 2 3, testing 1 2 3. If everything is working in our audio files, a file with a response to our test 1 2 3 message is supposed to be generated in the audio files folder. When we open the audio file, see that there are two files: the one that was downloaded for audio to text conversion and the one which was generated when we took the response from the AI and converted it into text. Go to its location using the finder. Open. Testing 1 2 3, testing 1 2 3. This is the one that we sent.
What's next on our creative agenda?
And this was the one generated by text to speech. So now it's time for us to send back the audio message to our user. And to do that, let us go to the WhatsApp service, copy the method for send message by URL, as the way we send the audio file is pretty much similar. So let us copy and paste it here and rename it to send audio by URL, audio URL. The type is audio, then audio. The way that it works is we're just specifying a resource that is available on our server to the WhatsApp API, then WhatsApp will forward that same resource to the user. Using the WhatsApp Cloud API, highlighting an audio and responding using an audio response is not supported. We can just remove the context here and do away with the message ID. Since we specify that we're going to be sending the generated audio file, which is in the audio file folder, we need to expose it externally. We need to make it accessible on the internet. You find that when we go on localhost, then / file, the server will say that it doesn't exist. Even when we do / audio file, the server will say that the resource doesn't exist. To expose our audio files folder for it to be accessible externally, let us go to our main file, use the static assets method to make our audio file accessible externally. You'll see that when we reload the application, let's remove the audio file part and reload. Testing 1 2 3, testing 1 2 3. The file is now accessible externally, meaning to say we can now send it. And in our controller, after we've converted the text into speech, the method is going to return the file path. Define a constant text to speech. Then if text to speech status is equal to error, we return. And if it's successful, using the WhatsApp service, we want to send audio by URL. We specify the message sender, then the file path, text to speech dot data. To make our code more cleaner, consider moving some of the logic in here to maybe a dedicated method, but I'm going to just leave it like that and leave it as an exercise for you guys to clean up the code a little bit. Before testing this implementation, we just have to make sure that the server URL in the environment file is the same as this URL provided by ngrok, since it's the one which is exposed externally. Otherwise, the WhatsApp servers won't be able to download these files. In our text-to-speech conversion, where we were returning the file path. Let us change it to file name and go to our chatbot. What is live? The URL has been fetched and the text has been converted into speech, but for some reason, we are not actually receiving the audio file. This is because the WhatsApp Cloud API expects the OGG file to be using a specific codec. Yes, we've saved it as an OGG file, but the WhatsApp API doesn't recognize it as a proper OGG file unless it has a specific codec. So even if we were going to save it as MP3 or any audio extension, if it doesn't have the proper codec, it's going to fail. So we need an extra step where we convert the text-to-speech file into a proper codec. So for that, we're going to use Fluent FFmpeg, npm install Fluent FFmpeg. And in our audio service, when we do the text-to-speech conversion, that's when we're going to convert it into an MP3 file using the proper codec. All is FFmpeg from Fluent FFmpeg. Then after saving the file, the one which was converted from text into speech, we then convert the file into MP3 using the proper codec. Then instead of returning the old file name, let's return the MP3 file name, which is the converted one that is going to work when we send it with the WhatsApp Cloud API. The more we interact with audio notes, the audio file folder is going to end up consuming space. How best can we deal with that? Please discuss with others in the comment section. I'm going to leave that as an exercise for you. With the conversion done, what is live? We have now received the audio message from our WhatsApp chatbot.
Life is a beautiful mosaic of experiences, each piece contributing to the bigger picture of who we are. It's a dance of joy, challenges, growth, and discovery. Anything particular you'd like to explore or talk about?
Always remember, when you face an implementation challenge, just break it down into smaller steps like we did in this tutorial. You'll see that things are not as complicated as they seem. With that, we've managed to integrate both speech to text and text to speech self-hosted for our WhatsApp chatbot.